Hello, this is me, or this is my presentation for my environmental pollution that I'd want to focus on. It's similar to, it's exactly the same on the thing that I did an essay on for, or at least the type of pollution that I'd want to try to bring attention to. Water pollution and innovative solutions for a sustainable future. So here I discussed a new, unique, and sustainable design aimed at addressing water pollution through innovative detection and monitoring technologies, or gold nanoparticles. They're used for sensors for effects detection, as sensors for effect detection. So here's some background info. Water pollution refers to the introduction of harmful contaminants in water bodies affecting aquatic ecosystems and human health due to industrial discharge, agricultural runoff, urban runoff, and improper waste disposal, what have you. It's used, my problem statement. The chemical pollutants found in the ocean or waters are bodies of water, such as or heavy metals such as mercury, lead, cadmium, arsenic, are among the most dangerous chemical pollutants. They enter aquatic ecosystems through industrial processes, mining, and proper disposal of waste. Heavy metals can accumulate in water bodies, affecting aquatic life. They can bioaccumulate in fish and other aquatic organisms, leading to toxicity in their tissues. This bioaccumulation can disrupt the food chain and cause reproductive and developmental issues in aquatic organisms. Humans are exposed to heavy metals through eating fish or through the waters or consumption of water or direct contact. These pollutants can cause neurological disorders, kidney damage, a whole lot of mess in our body. So my proposed solution is using AUNPS-based sensors. Introduce these very complicated things. AUNPs offer high sensitivity and selectivity, enabling rapid detection of a wide range of contaminants. So it's designed very specific. So here are the key components. So gold nanoparticles core the sensor with unique optical properties that are commonly at the core of these sensors. They exhibit unique optical properties, most notably surface plasmon resonance, or CPR, which allow them to absorb and scatter light strongly. When these nanoparticles aggregate or disperse, they change color, providing a simple and effective visual readout for detecting contaminants using colorimetric detection. Visual color change indicates the presence of target contaminants in water. Functionalize AUNPs, the functionalization of gold nanoparticles with various biomolecules is what makes them versatile in biosensors. They can be antibodies, nucleic acids, or aptamers, which give the sensors the ability to recognize and find specific targets with high selectivity. My portability and cost effectiveness. It's to have durability and to an ease of use. The sensor housing is designed to be robust yet lightweight. It contains compartments for regions and simple detection mechanisms, making the sensor suitable for portable on-site use. So fewer moving parts, simple operation, reduces maintenance needs. And detection mechanisms. The most straightforward detection mechanism is visual observation of color changes, obviously, often indicating the presence of specific pollutants. For more precise quantification, some sensors use optical readers to measure color shifts, providing accurate readings. Now with the innovation claim, here I have my SPR. Since taking all the things that we've stated already, I think these would be highly effective in making sure that our waters would stay, or at least reduce the amount of pollutants already found in water, or at least be able to prevent certain organisms being already exposed I suppose less exposed. So the benefits of these sensors would obviously be to be improved water quality, environmental sustainability, public health, cost effectiveness, and portability, and enhanced sensitivity and selectivity. Broad applicability, pretty much. It's also applicable in air quality monitoring, soil analysis, medical diagnostics, and demonstrating versatility. So it's extremely versatile. Integrating technology, IoTs is one that I thought of. Connectivity and real-time monitoring. IoT fundamentals. Well, IoT obviously is a network of connected devices that share data. Now, over the internet, or environmental sensors that send data to central systems for analysis. So, real-time data collection would be amazing. It would enable real-time monitoring, allowing for quick detection and response to pollution changes. Especially if it's remote accessibility. It would allow remote monitoring, enabling environmental tracking without physical presence, proactive pollution control with IoT, early detection and automated alerts and notifications, integration with control systems. The works. So the role of AI is another one. In analysis and decision making, advanced data analysis, processing large volumes of data, obviously, identifying patterns and trends, anomalies, what have you, predictive analytics, automated decision making. That one's still iffy. Applications in environmental monitoring, smart cities is a bit of a reach. Industrial monitoring, and agriculture and forestry is a big one. Applications in environmental monitoring. I think I've just restated. Challenges and considerations. Data security is obviously a big one when you're working with large amounts of data and privacy. Interoperability. Integrating IoT and AI across different platforms would require standardization. Cost and scalability. Implementing IoT and AI-based sensor systems can be extremely costly. Scalability is definitely important. Key, honestly, it's the foundation of the entire infrastructure. Potential impact, early detection and pollution control in aquatic ecosystems, prevention of harmful contaminants, preservation of water quality, protection of aquatic organisms, reduction of eutrophication, controlling pollution from agricultural runoff reduces the risk of eutrophication, preventing oxygen depletion and preserving aquatic life, biodiversity, health risk reduction through detection of pollution control, safe drinking water, reduced exposure of toxic substances, safeguarding food sources, prevention of environmental exposure. Collaboration and partnerships. Collaboration among governments, industries, research institutions, and communities is essential for implementing sustainable solutions for an environmental monitoring and pollution control. It would take the collective efforts, essentially, to be able to implement this on a broad scale if it were to be taken further, which would require other factors such as certain policies being implemented already. It would involve the agreements of certain institutions. It would require a lot of handshaking and nodding, essentially. The challenges and risks, reducing e-waste, recycling and reusing, extended producer responsibility, EPR. I'm not entirely sure on how that would look like. E-waste collection programs, it would be pretty much everything that's already being applied. Conclusion, gold nanoparticles-based sensors offer a pretty versatile and cost-effective solution for combating water pollution. But it's more or less a catalyst for solutions already implemented. I think focusing on it would definitely help, especially everything else that it could be applied to, such like air pollution. We can achieve efficient monitoring, early detection, and effective pollution control, contributing to a healthy environment and improved public health. And I think stakeholders and continued research into innovative sensor technology will further advance our ability to address water pollution and promote sustainability. And my references.